So when we use the imaginary numbers, nothing is really changing from what we've done the past 2 or 3 days. Okay? The only thing different here is now that it's going to have an I, or it's going to have that variable that we're using to represent that -1 that's underneath the radical. Okay? We solve everything the same way, we simplify it the same way, nothing changes there. Questions on that? Okay. So even if we solve, so like on 3, if I have 2x squared plus 26 equals -10. What did we do yesterday whenever we solved it? We had to isolate, right? So what are we going to do to isolate the x? Subtract the 26. So 2x squared equals -36. Now what? Not yet. Divide by 2. There we go. So x squared is equal to -18. Now, just like yesterday, okay, the only thing different is that it's going to be a negative on the other side. It's really the same steps. Everything that we did yesterday is going to transfer over to today until this very last part. So if we take the square root of both sides, I need to break up, so I'm going to have a plus and a minus. That negative gets pulled out. That's going to be what? An I. Okay. How are we going to break up the 18? 9 and 2. So I have an I have the square root of 9, and I have the square root of 2. Now, what's the square root of 9? 3. Okay, so x is equal to plus or minus 3i times the square root of 2. Same way with 4. Now it's a little bit different, just like it was yesterday, to where now we have a parenthesis. So what do we need to get rid of first on 4? Get rid of the -1/2. Okay, whenever we get rid of that -1/2, I'm going to multiply both sides by -2. So on the left side, I'm left with x plus 1 quantity squared equals -10. Now what do I need to do to get rid of the squared? Square root. So the left side is x plus 1. Now, how can I simplify this side over here? Can I factor out a perfect square, first off? No. How do I get rid of that negative? Or what do I need to pull that negative? If I pull the negative out, what needs to go on the outside? An I. So it's going to be plus or minus I times the square root of 10. Okay. This is going to be pretty simple because there's nothing I had to do to the 10, so it's just going to, all I have to really do is pull that negative out and put an I in front of it. Now, making sure that you put the I between the plus or minus and whatever my radical is. Okay, now how do I get rid of the plus 1? Subtract 1. So, x is equal to -1 plus or minus I times the square root of 10. And it's just going to stay like that. Nothing's going to change here. Okay, the only thing different from yesterday to today is yesterday we didn't have an I, now you do. Then at the bottom it just says that we have adding and subtracting complex numbers. So a complex number puts a real number and an imaginary number together in the same expression. Okay? So you always put the real number, whenever we write a complex number in standard form, we always put the real number first, and then we put the imaginary number second, because you always want to put your real friends in front of your imaginary friends. Okay? Because you might forget about your imaginary friends at some point. You combine the real parts, you combine the imaginary parts, and you just kind of go from there. But other than that, it's really no different than whenever you had any other variable. So like if we're going to add things and I have 5 minus 2i plus negative 6 plus I can drop the parentheses, and really if you want I can rewrite it, or you can just add it. It really doesn't matter to me. Okay, I'm just going to rewrite it and drop the parentheses. I'm going to add my real parts together. So 5 minus 6 is negative 1. Negative 2 plus 1 is going to be a negative 1i. Real number goes first, and I'm done. You treat it just like any other variable. Okay? You treat the I like you would a Q, an H, a Z, whatever you have. Okay? It's no different. Now, making sure whenever you subtract, though, that the biggest mistake that gets made is not with the first part, with the 3 minus 5i, and usually not with the minus 9, but making sure that that negative goes to both parts. Okay? So I need to make it a negative 2i. If there's a mistake that's going to get made, it's going to look something like this, and it's going to be 3. Do not write this down. It's going to be like 3 minus 5i, and then the students are going to go minus 9, and they're going to go plus 2i, because they're not going to change that sign because of the negative. And then they're going to solve it, and they're going to get negative 6 minus 3i, and they're going to be like, yeah, I got it right. And then what am I going to do on the test? I'm going to be like, no, you didn't. Every now and then. So make sure if you have a negative, addition's usually not a problem because there's nothing you have to change. It's when you have a negative that you've got to make sure that that negative hits both parts, and that negative 2i gets changed, so then I can have negative 6 minus 7i instead of negative 6 minus 3i. And I know it's going to happen. Okay? Somebody's going to get in too big of a dang hurry, and they're just going to rush right through it, and they're going to forget to change that second sign. It always happens. Okay? Somewhere, sometime, it will happen. Then, last part. Okay? And I'm not going to go through the examples on 7 because I feel like you can add and subtract pretty well. I would hope so by now. So, whenever you take the absolute value of a complex number, so this is where we're going to get into more like the engineering side of things or the physics side. That's where you're going to see this a lot more. So, whatever you have, if you have the absolute value of a complex number, okay, whatever your real number is, all I'm going to do is I'm going to put it underneath the square root, okay, and I'm going to put the whole thing. So I'm going to put A, and I'm going to square it. I'm going to take whatever coefficient is in front of my imaginary number, and I'm going to square it as well. Even if it's negative, the whole thing gets squared because it's going to be a positive number underneath the radical. Okay, you should never get a positive or a negative number, excuse me, underneath the radical of the absolute value of a complex number. Okay, remember, it's absolute value. It's just all it is a distance. Okay, distance is always positive. So even if you have to say, well, A in this case is negative 3 and B is negative 7, all you have to do is take the square root, and I'm going to go A squared, so I'm going to take negative 3, and I'm going to square it, and I'm going to add that to negative 7, and I'm going to square that. Anytime you square that negative, make sure you put it inside a parenthesis. Okay? So whenever I do that, I'm going to have the square root. I'm going to have 9 plus 49. So I'm going to have the square root of 58. Now, if you can simplify it, simplify it. If you can't, just leave it like that. So what's square root of 58? Can I factor anything out? Can't factor out a 49, can't do a 36, 25, 16, 9, 4, 1. There's nothing I can factor out, so it's just going to stay exactly as is. Okay, and just be the square root of 58. Okay, there's really nothing different from what you did yesterday in terms of how you solve it and the steps that you take. The only thing that's going to be different is that now you're going to have a negative, which is going to make it imaginary and have an I out in front of that radical. Your assignment's on Canvas.